Okay, so welcome back, everybody. So I am here with a few members of the Faculty of Applied Science who are going to share with you their amazing research and just some of the ways that engineers are making an impact in the world. This research is often interdisciplinary, meaning that people from different engineering programs or faculties like science and medicine all work together. Hopefully, these short introductions to just some of the research happening at our faculty will give you better insight into the variety of topics a degree in engineering may allow you to explore. Engineering research and the application of this research is truly changing our world for the better. With that, I will invite our first research spotlight, and she's already here on the stage with us. So I'd like to introduce Mahsa Mohammadi. Mahsa is a lecturer at the School of Engineering at the UBC Okanagan campus. Prior to joining the UBC faculty, Mahsa was a lecturer in operations, research, and management science at Shannon School of Business at Cape Breton University. Mahsa's research focuses on operations, research, and management, logistics and supply chain analytics, decision support system design, and disaster management. She will be speaking about the adoption of new technologies for logistics and transportation management today. So, Mahsa, before we begin with your presentation, could you share why you decided to pursue a career in engineering and why did you choose your field of study?
Hello, everyone. Thanks, Mary, for the introduction, and thanks for having me here online. I chose engineering because I've always been passionate about problem solving and creating solutions to see their impact on the real world. So engineering allows me to apply critical thinking to real world problems. And I chose my field, industrial engineering, because I'm fascinated by how systems can be optimized for sustainability and efficiency, specifically in the face of disruptions, disasters, either natural or man-made.
Thank you so much for sharing that. That gives us just a little introduction of right before you're going to go into your presentation. So I'm super excited to hear what you're going to share with us today. I'm going to just add your slides here to the stage, and then you can share with us a little bit about your research.
Thank you, Mary. So today I'm going to start my presentation with some questions, and we are going to answer those questions in this presentation. Have you ever wondered how products travel from one country to another country and how different companies all over the world trade with each other, or how the novel technologies can be used to deal with the challenges that such companies have in trade with each other? Now let's take a look at these figures, which are statistics about three countries, the United States, Mexico, and Canada. It seems that the economic growth in these three countries are complementary, which means that, for example, the United States excels in manufacturing and resources, while Canada excels in agriculture. So balancing the trade across these three sectors is crucial for economic growth and regional stability. Now we are gonna delve into the wide world of NAFTA, North America Free Trade Agreement. This trade agreement signed back in 1994 with the aim to make the North America a free trade paradise. What was the goal? To tear off those pesky trade barriers between the United States, Mexico, and Canada. Think of it like this: no more tariffs, no more codes, just a beautiful free-flowing river of goods and services. It's great, right? But like everything in their life, it is much more complicated than that. Now, let's be fair. NAFTA did have some wins. The economic in these three countries skyrocketed. We saw more integrated economies and even, yes, cheaper avocados. But here is the kicker. NAFTA came with some serious baggage. I'm talking about environmental degradation and logistical nightmare. And let's not forget those uneven benefits between these three countries. Now let's remember that free-flowing river of goods and services again. It looks like it was mostly made of a diesel fuel. The more trucks means more traffic, more congestion, and yes, even more road rage. Here is another truth about the NAFTA. The benefits weren't shared exactly equally. For sure, all three countries saw economic growth, but as always, the United States grabbed the biggest slice of the pie. The Mexico, despite seeing boom in manufacturing, but faced significant challenges such as environmental degradation and logistical nightmare. It's like inviting your friends over for a pizza, you eat most of it and leave them just with crumbs. Not cool, right? So, all these challenges come to the poor supply chain management and poor information sharing. Now let's take a look at the solution. Here is the solution. It might look a little bit complicated, but I'm going to break it down to two main parts: the well-organized supply chain network and well-organized information sharing. Now let's see what is the supply chain network. The supply chain is a network of suppliers, manufacturers, warehouses, and distribution centers. And the supply chain management is the coordination between these echelons in terms of services, goods, and information from the raw material to the final products in order to ensure the efficiency and cost effectiveness. In terms of the information sharing, I'm not talking about building a wall. I'm talking something far more revolutionary. And yes, that's the blockchain. The blockchain is a technology behind the cryptocurrency, but it is a little bit complicated than that. Let's assume a digital ledger spread across multiple computers, and it records every transaction in an incredibly secure and transparent way. That's the blockchain nutshell. Now you might think it's a bit too good to be the truth, but the truth is the blockchain is being used to revolutionize supply chain all over the world. Take the Walmart as an example. They use the blockchain technology in order to track mangoes from Mexico all the way to your local supermarket. Another example can be referred to Mars, a giant shipping company, global company. They use the blockchain technology in order to streamline their operation and reduce the paperwork in order to increase the transparency and efficiency. Now let's see how these fancy blockchains solve the real world examples, the real world problems like NAFTA's mess. With the blockchain technology, you can track every single shipment in a real time. For example, you will have an idea where did it come from, what's inside it, and who's responsible for that. No more shady dealings, no more hiding or hides behind the layers of the bureaucracy. It's like putting the whole supply chain under a very giant and powerful supply chain network microscope. Long story short, the supply chain management helps us to build a more sustainable and equitable global trade system. In terms of the information sharing, the blockchain technology integrated to the supply chain network revolutionized the way that we produce, transport, even consume the product. So realizing this potential requires actually collaboration, coordination, governmental support. So this is the point that we need to decide whether we want to be drivers or passengers. Thank you.
Well, thank you so much, Mahsa, for sharing a nice insight snapshot into your research. It's so interesting to see what you're working on. To wrap up the presentation today, I was hoping you could share with us how your research informs your teaching.
Well, my research informs directly my teaching by bringing real world examples, real world problems into my class. So it provides the students with the hands-on experience and the latest tools, methodologies, algorithms and the novel technologies, providing them and preparing them to deal with the real world problems.
That's great. It's so interesting to hear how we can combine that cutting edge research with what students are learning in the classroom. So I really appreciate you taking the time today to share that with us. I'm going to bring our second speaker up on the stage. So thank you so much, Mahsa.
Thanks again for having me here.
Okay, so now I would like to introduce Dr. Christine Chen. Dr. Christine Chen is currently an associate professor with the Department of Electrical and Computer Engineering at the UBC Vancouver campus. She teaches undergraduate and graduate courses in electric power and energy systems. Her research interests include power system analysis, control, and operation, with an emphasis on renewable integration. Dr. Chen will be speaking about decarbonation and electrification, perspectives from the electric power system. So Dr. Chen, before we dive into your research, I was wondering if you can tell us a bit about your lab and how undergraduate students can get involved.
Yeah, absolutely. Thanks for this opportunity, Maria. I really appreciate the chance to talk to some incoming students potentially. So like you nicely introduced, my lab works on power system control and operation, and with an emphasis on integrating more renewable resources into the electric power system. And really, in a nutshell, for the layperson, it's how to keep the lights on without contributing to greenhouse gas emissions. And we're really focused on the sustainable energy transition from the electricity system perspective. In terms of how to get involved, just reach out to me. I think there are many opportunities for undergraduate research in terms of summer research terms, thesis projects, even co-op terms. And I think in general, a piece of advice I would have is to just talk to your professors that you're taking classes with, engage with them during lecture, go to their office hours, ask questions, ask about opportunities directly if you are interested. Professors tend to be very passionate about their field of research. And so generally, we're very happy when students are interested and want to get involved. And I think otherwise, there are just many opportunities at UBC to join also student-led initiatives to build up some of your experience and resume and et cetera. For electrical engineers, for example, off the top of my head, I can think of Solar Car, the e-kitchen, Campus as a Living Lab, different design projects, just to name a few. Yeah.
Well, thank you for sharing that. It's always great to be able to share that in advance for students interested in pursuing a degree in engineering at one of our campuses, to just know that research is an option, and it's nice to have a little sneak peek into what they could get involved with if they're interested in going into electrical engineering. So I'm going to share your slides now so you can start talking about a little bit about your research.
Perfect. Thanks. All right, so this is the title slide, but we'll jump right in. As we all know by now that climate change is really wreaking havoc on our planet. The impacts in terms of droughts, floods, heat waves, and many other extreme climate events are now causing enormous suffering for people, animals, and our ecosystems. On the slide here, I have a picture of a wildfire burning on the side of a mountain here in British Columbia from a fire in 2021 when we had a heat wave here. And it led to many health-related issues for people, as well as even deaths. And we now know also that these climate events affect critical services as well, like hospitals, water shortages, transportation systems, as well as what's important to this talk and my work, power grids. And we now know also that global warming, due to the overwhelming amount of greenhouse gas emissions from burning fossil fuels, is really the underlying cause. And so Canada and many other countries around the world have decarbonization goals. And in particular in Canada, our goal is to achieve net zero emissions across the entire economy by 2050. And so in this middle chart, I show some main sources of greenhouse gas emissions. And you can see maybe big chunks are in transportation, in electricity itself, in heat, industry, agriculture, and so on. And so it's clear that this goal of having net zero will not only be achieved by reducing emissions in any single sector alone, but rather across everywhere possible, across different sectors, different economies. Now, a major issue in decarbonization is kind of this distributed nature of emissions. So a really canonical example is millions of cars or vehicles or trucks emitting greenhouse gases when fossil fuels are combusted, millions of buildings that use fossil fuels or natural gas for space heating or cooling, which are also emitting a significant amount of greenhouse gas emissions. But when kind of these energy end users are electrified, in the sense that they, instead of burning fossil fuels, they use electricity, then no greenhouse gas emissions are done at the point of the consumption. And so economy-wide GHG reduction can really be quite significant if we consider this path of electrification. But of course, the caveat is that the source of the electricity that is providing energy for these end users is in fact also decarbonized. And that means that we need to integrate much more renewable sources like solar and wind into our electricity supply. And if we take a look at some of these options, wind and solar in particular, which are really cost-wise on par with some of the more, natural gas plants, for example, more traditional fossil fuel-based plants. So you can see from these charts, I hope, that there are operational concerns that stem from uncertainty and variability of renewable generation, because they are, in fact, dependent on weather patterns, for example. And so in this wind farm output, you can see, every single line is basically a day's worth of output from a single wind farm. And you can see this average line is really not representative at all of any given day. The story is sort of not great on the solar side either, where you can see that instead of a smooth kind of nice curve, we have this, very rapid up and down depending on whether clouds are coming in or not. So this quote is taken from a recently published discussion paper on the clean electricity standard with the Canadian federal government. And basically it says that in order to offset the intermittency or variability in renewables, we need a sufficient firm supply as backup. And so this is analogous to, if you have a car, you want to equip your car with a spare tire in case one of the tires, blows out or breaks. And so having more renewables in the system means that you're going to need more and more spare tires in order to integrate more renewables on the supply side. Now, if I can shift gears a little bit and give a crash course on power systems through these three intersecting pillars, we basically, historically, when power grid first started, we were very much interested in the infrastructure and reliability. And roughly speaking, we can think of reliability as basically having lights when we want to have them. And access to reliable electricity is really a hallmark of developed countries and industrialization. And at the same time, we want to deliver this power with sort of as low cost as possible. And so the economic side of things come in. This led to the creation of electricity markets in North America and around the world. And more recently, environmental concerns have sparked new interest, problems, and opportunities. And like we talked about earlier, renewable integration is really critical here. And we have seen that the kind of this intermittent and variable nature of renewable generation can create real problems for reliability. And so that maybe, you know, we no longer have lights when we want them. And to solve this, we saw that we need to have enough spare tires, so to say, enough backup. But the problem with this solution, with having, you know, increasingly many more spare tires, is that it can become prohibitively expensive as the penetration of renewable increases, and that makes electricity less affordable for us as people who use them as customers, and so that's not a desirable outcome. As a result, there's this second part of this quote that I hid previously, but we also need to explore other options. And these other options are really in exploring flexibility and control, as well as markets and regulations. And examples are, you know, very simple example is using battery storage, for example, to shift the amount of supply, electricity supply in time, or demand response in order to incentivize customers to, you know, run their washing machine at, you know, midnight instead of at a peak time when everybody else is also running them. So this is a problem that really crosses traditional disciplinary boundaries, because we're talking about many relatively small energy resources distributed across the grid, and these are owned by many individuals with diverse needs, values, and preferences. And so with this kind of context in mind, my research group works on kind of several different intersecting domains, all related to integrating more renewables into the electric grid. So here at the bottom, at the grid level, we're interested in developing models and tools to enable reliability and efficiency as the demand for electricity continues to increase because of electrification, as well as the supply of electricity becomes less predictable. And we're interested in coming up with tools that can help with this. And in order to do this, we need indeed accurate forecasts of renewable generation, as well as new types of demand like EV charging, which is kind of different from traditional types of electricity demand that we've dealt with in the past. We also need fast solutions of large-scale optimization problems. And promising solution methods kind of in this domain include like recent advances in deep learning, for example, and graph neural networks, or AI, or you know, artificial intelligence in general. Finally, we need at the top some kind of market framework that can provide appropriate financial incentives to further investment into renewables, but at the same time ensuring affordability for customers, as well as reliability and efficiency that we've become used to. And having all these three layers work together harmoniously will help to achieve that kind of high penetration of renewables that's really needed to serve the additional demand for electricity due to electrification, which will then, you know, is necessary to realize decarbonization that then help to reduce greenhouse gas emissions, and so on. So in short, my research in power systems focused on renewable integration will contribute to a more sustainable and affordable energy ecosystem. And this is all toward combating the effects of climate change.
So, Dr. Chen, thank you so much for giving us that overview of your research. And I really noticed that all the topics you're talking about seem that They would involve probably many departments on these different research topics, bringing in their expertise. So I was wondering if you could also just touch on a little bit about the interdisciplinary nature of your research, and if there's other departments that you work with on some of your research.
Yeah, absolutely. So I hope I've been able to convey in that short little talk that the electricity system is not simply this massive interconnection of cables and power plants and just simply technical infrastructure. It's actually a really highly dynamic system and is tightly coupled with technological innovation, policy decisions, environmental challenges, and really increasingly more and more active customer and community participation. And so while we know that the choice to embrace and scale up renewables is very clear, actually making that massive transition away from what we currently have, what the status quo is, will require a combination of engineers, planners, economists, policy analysts, and so many others to work together. And we need to devise system level strategies that are technically viable, financially favorable, but also socially implementable. And so unsurprisingly, there are many departments across UBC who do work on related areas, and lots of examples, but off the top of my head, I can think of the School of Public Policy and Global Affairs, the Institute of Resources, Environment and Sustainability. Sauder Business School has work in sustainability as well, geography, and even colleagues in psychology. They do research into how to ensure that people would actually participate in certain electricity conserving or energy conserving programs. So lots of, I think, opportunities at UBC for work in related areas.
Thank you so much for sharing. It was really great to learn about your research, how students get involved, and how you work with other departments on campus. I really appreciate your time here today, and I know all of our viewers do as well, and I'm sure they learned lots about electrification and decarbonization. So we really appreciate you taking that time today with us. I am now going to introduce our third speaker and bring them on the stage. So hello, Saba. So Saba is our third and final speaker for our research spotlights here today. Saba is currently pursuing a PhD in civil environmental engineering at the UBC Okanagan campus with a focus on sustainable healthcare systems. Her research revolves around developing a decision support framework for sustainable kidney care practices, where she analyzes kidney replacement therapies through life cycle sustainability assessments. Saba is passionate about creating practical solutions that improve environmental efficiency in healthcare while ensuring high quality patient outcomes. Saba's presentation today will focus on engineering a sustainable future for kidney care management. So welcome, Saba. We're so happy to have you here today. Before we get into your presentation, I was just wondering if you could just tell us a little bit about how you got involved in research. For instance, maybe how you selected your laboratory for your graduate studies, or how you knew this was the area that you wanted to pursue.
Hello, thanks Mary for the introduction and for having me. Good morning, everyone. So we all know that climate change is one of the pressing global issues, and coming from a country which is highly impacted by the environmental impacts, I have always been passionate about sustainability and to develop sustainable strategies. Well, engineering is a very versatile field which makes it applicable across almost everywhere and all the sectors. 3 years ago, when I began my role as an environmental engineering analyst with Vancouver Coastal Health, I was amazed to see by the significant impact of different life-saving treatments that could make. This experience was like a turning point for my career, and I soon realized that this is where I want to make a meaningful contribution. Yeah, so this is like a bit about like how I come into the engineering and healthcare field.
Well, thank you so much for sharing that. It's really interesting to learn how you've chosen to pursue the path you have, and we're so happy you are doing this because I know your research is very exciting. So I'm going to bring your slides up right now, so you can share with us a little bit about your research.
Sure, thank you. Yeah, so this is just like introduction slide about my presentation, a little bit about myself. So I have like one bachelor's and master's in environmental sciences, and then I also did one master's in environmental engineering. Currently, I'm working as a graduate research assistant at UBCO School of Engineering in the Life Cycle Management Laboratory. And as I explained, that my work focus on sustainable kidney care services, and where I am hoping to develop a decision support framework for sustainable kidney replacement therapy. And I will talk about it more in my presentation. So, climate change is impacting our health more than ever before. Approximately 12.6 million deaths per year, or 1 in 4, are linked to the environment. Several human factors are responsible for this change and its related disasters. Whenever we think about healthcare, we often focus on wellness and healing. What we tend to overlook is its significant contribution to environmental pollution. Healthcare is essential, but it is also resource intensive, contributing to environmental footprint. As per Lancet 2021 report, between 2030 and 2050, climate change is expected to cause approximately 250,000 additional deaths per year. Therefore, it is very important to have a resilient and sustainable healthcare system. Kidney care services like dialysis and kidney transplantation, they are life-saving interventions but come with significant environmental impacts. Given the growing number of patients requiring kidney care worldwide, it is essential to balance healthcare efficacy with sustainability. That's where engineering tools can offer a structured approach to address these challenges. Life cycle assessment is a well established tool that evaluates the environmental impacts of a product or process throughout its life, which means that we can identify and quantify the environmental impacts of anything from the point of its generation, raw material extractions, its manufacturing process, materials processing, its distribution phase, use of the product, and finally, end of the life. By assessing the carbon footprint, life cycle assessment helps identify opportunities for reducing environmental burdens and promoting sustainability within the healthcare sector. Lifecycle Management Laboratory at UBCO is a world-class facility specializing in lifecycle assessment of the built-in environment. It is the only research facility in Western Canada focusing on lifecycle assessment of the built-in environment. By collaborating with several industries, profit and non-profit organizations, we are focusing on developing innovative methods, technological solutions, and decision-making tools. In my doctoral research, collaborating with Canadian healthcare authorities, I aim to evaluate and quantify the environmental impacts of different kidney care services, particularly dialysis and kidney transplantation. My work involves conducting a life cycle assessment to understand environmental, social, and economic impacts of these services, creating a guide for making sustainable choices and ultimately developing more resilient and sustainable kidney care services. This research work is very important because it directly addresses the growing need to make healthcare system more sustainable and provide strategic roadmap to integrate life cycle sustainability into the overall decision-making framework of kidney care services. Thank you.
Thank you so much, Saba. That was really great to learn about your research. I learned so much from that as well. I didn't even realize this was being done at the Okanagan campus, so it was really great to hear about that. So as we wrap up our research spotlights this morning, I was hoping you could just share with us what your plans are for after graduation.
Yeah, so my immediate goal is to obviously first complete my PhD work and then to work with healthcare organizations to implement the dual decision support framework. I aim to collaborate with interdisciplinary teams of different healthcare facilities and engineers, and to develop more innovative solutions that could improve and bring sustainable kidney care without compromising the patient care.
That is great. Thank you so much for providing that insight. And thank you so much for being here today, Saba.
Thank you.
So I just want to say a really big thank you to all of our research spotlights here today. So we're going to be right back here on the stage in a few minutes for our Why Engineering presentation. We're going to share a little bit about engineering and what it's like if you want to attend engineering at UBC. We'll see you in a few minutes.